Okay, so today let's dive into the work of a specific research lab, one that's really making some noise in AI. It's the INHA Big Data Lab.
Yeah, we've gathered some material, their website, some articles to really get a handle on their focus.
And what they're trying to achieve.
Right.
Yeah.
And the big headline, you could say, is their mission, AI for good. But they make it more concrete than that.
How so?
They've got this technical goal, making AI more accessible, scalable, and reliable.
Accessible, scalable, reliable, ACR.
ACR, yeah, you could call it that. It's a neat way to frame it.
So ACR for AI, what kinds of technical problems are they actually tackling to make that happen? Especially with these massive models, the deep neural networks, DNNs.
Well, their core strength comes from combining machine learning with serious big data chops.
Okay.
So think machine learning, data mining, databases, even computational theory, that whole mix.
Right. The foundations needed to handle huge AI. And this deep dive, it's really about looking at their actual research, isn't it? Seeing what accessible, scalable, reliable means, like on the ground.
Exactly. Not just buzzwords, but what the problems they're solving. Let's maybe unpack that mission pillar by pillar, starting with accessibility.
Okay, accessibility, what does that mean in their context?
It really boils down to understanding what's going on inside these trained DNNs.
Yeah.
How do you, extract the knowledge they've learned?
Extract it and maybe reuse it.
Reuse it, potentially, yes. And crucially, how do you get the AI to explain itself?
Ah, so moving away from the whole black box problem, making it understandable.
Precisely. Which leads straight into a big research theme for them. Interpretable, explainable, and interactive AI services. You hear it called XAI a lot.
XAI. Yeah, that's huge everywhere right now. Makes sense. You need trust.
Absolutely.
Yeah.
Especially if AI is making decisions in, say, healthcare or finance.
Mm-hmm.
You need transparency.
So what's their angle on XAI?
Their goal, from what we've seen, is for the AI to generate explanations that aren't just, technically accurate dumps of data,
Right.
but explanations that are relevant to you, understandable by you, and ideally actionable, something you can actually use.
So it's about having a kind of dialogue with the AI's reasoning.
Yeah, exactly. Making its thinking useful.
Okay, that covers accessibility. What about the S scalability? Models keep getting bigger? That sounds like a nightmare.
It's definitely a major challenge. And for them, scalability seems to mean two main things.
Okay.
First, how do you keep the AI learning over time? How do you update a trained DNN incrementally efficiently?
Without having to, start from scratch every time new data comes in?
Exactly that. That's the core of continual learning, sometimes called lifelong learning or incremental learning.
Right.
Think about AI in the real world. Things change constantly. The AI needs to adapt.
And learn new things without just, poof, forgetting everything it knew before.
Yes, that's the key problem. Catastrophic forgetting. A big hurdle.
Catastrophic forgetting. Sounds bad.
It is like learning to recognize dogs makes it forget how to recognize cats. Not good.
So how do they approach that?
Well, the sources mentioned they're actually looking at how the brain handles this, studying biological mechanisms for inspiration.
Trying to build brain-like incremental learning into algorithms. That's fascinating.
It really is. So that's one side of scalability. Continuous learning.
Okay, what's the other side?
Practicality. Deployment. These huge AI models need massive computing power. How do you get them to run, well, everywhere?
On smaller devices, like phones.
Exactly. Phones, embedded systems, edge devices, places without giant servers. This brings us to their work on neural network compression.
Compression, so shrinking the models.
Yep. Making them smaller, faster, less power hungry. Efficient deep learning is the broader term.
How do they do that?
Various techniques, things like pruning, cutting out less important connections, or quantization, using less precise numbers. Basically slimming the model down.
But without losing too much performance, presumably.
That's the tricky part. It's all about the trade-offs. Size versus speed versus accuracy. Their research explores how to optimize that.
Got it. So scalability is both learning over time and fitting onto real-world hardware. Makes sense. What about the last letter, R for reliability? The sources mentioned fixing errors.
Reliability is interesting. It doesn't seem to be one single research topic name like XAI, but more of an underlying goal.
Okay.
It's about making sure the knowledge the AI learns is, well, correct and robust. How do you repair things if it learns something wrong? Or reorganize knowledge?
So it connects to the other areas. Like in continual learning, new info could cause errors.
Exactly. Preventing or fixing errors during updates is key. But it also ties very closely into another quite unique research direction they're pursuing.
Oh, What's that?
It's something they call human-like recall of neural networks.
Human-like recall. Wow. Okay, that sounds ambitious.
It is, but the idea is grounded in making AI more adaptable. Think about how human memory works. We store vast amounts of information, retrieve relevant bits when needed, adapt flexibly.
You mean like remembering past experiences to solve a new problem?
Sort of, yeah. Enabling neural networks to store and retrieve information more like we do. This is super important for AI in dynamic settings. It needs to adapt, maybe correct itself based on past info.
So it's not just about learning, but remembering and using memory effectively.
Exactly. And again, they're looking at human memory mechanisms to guide the AI algorithm design here.
So reliability isn't just error prevention, it's building in this more flexible, memory-driven adaptability.
That seems to be the goal, making AI more resilient, more intelligent in how it handles the ongoing stream of real-world information.
Okay, so we've got the ACR framework, accessibility via XAI, scalability via continual learning and compression, and reliability underpinning things, especially with this human-like recall idea. Let's maybe zoom in on a few other specific research areas they list.
Sounds good. We've hit continual learning and XAI pretty well. Another big one is collaborative learning, specifically federated learning.
Federated learning. Okay, I keep hearing that term. What's the core idea?
It's basically a way to do machine learning across multiple different devices or organizations without them having to share their actual raw data.
Ah, so training a shared model but keeping the data private, like on everyone's individual phone or server.
Exactly. Think about the privacy implications.
Yeah.
You could potentially train much better models using diverse data from many sources.
Without anyone having to expose sensitive information. That's huge.
It really is.
Yeah.
But it comes with its own challenges, of course.
Like what?
Well, how do you ensure the model actually performs well when trained this way? How do you make sure it converges properly? How do you make it robust if some participants have weird data or are maybe even malicious?
Right. Lots of technical hurdles, so they're researching solutions for that.
Yes, tackling performance, convergence, robustness in these distributed privacy-preserving setups.
Okay. And just to recap, we also covered neural network compression for efficiency.
Right, getting AI onto smaller devices.
And the human-like recall idea for adaptability.
Yeah, giving AI a better memory system.
It strikes me that underneath all this AI work, they must have a really strong foundation in just handling data itself.
Absolutely. Their background research interests listed include things like big data management, analytics, data mining, I/O-efficient algorithms, graph data, even computational geometry.
So the skills to actually manage and process the massive data sets needed for modern AI?
Precisely. That blend of deep data systems knowledge with cutting-edge machine learning seems to be their special sauce, you could say.
Makes sense. So who's the person leading this effort? Who's behind the lab?
The driving force is Professor Dongwon Choi.
Okay, tell us a bit about him.
He's an associate professor there at Inha University. He actually did his undergrad at Inha too, but his PhD is from KAIST, a top Korean research university.
Was it right?
And his PhD thesis, which was on spatial databases, actually won an outstanding thesis award there.
Impressive. Databases. So that connects to the big data angle.
Definitely. And before coming back to Inha, he did postdoctoral work internationally, Simon Fraser's University in Canada, and significantly, Imperial College London.
Ah, Imperial College. And the sources mentioned he was just back there recently.
Yeah, as a visiting scholar for all of 2024. So strong international connections too. That background in databases and data mining really grounds the lab's work.
It seems like he brings that data rigor to the machine learning challenges.
I think that's a fair assessment.
And the lab itself, they seem pretty focused on publishing. The sources mention solid papers in top-tier venues.
Oh, absolutely. They're aiming high. We're talking major conferences and journals in ML, big data. Databases, places like ICML, NeurIPS, ICLR, AAI, KDD, SIGMOD, VLDB, ICDE.
Wow, those are the big names.
Right. Publishing consistently there shows their work is being recognized as significant on a global scale.
Any recent highlights? What pops out from their latest news or publications list?
Quite a few things, actually. There's a paper just accepted in the Neural Networks Journal coming out early 2025.
Okay, what's it about?
It tackles out-of-distribution detection, but specifically within federated learning. So how does a collaboratively trained model handle data that looks totally different from anything it saw during training?
Ah, so
Yeah.
linking that federated learning work with reliability concerns.
Exactly. And it also credits one of their MS alumni, Guban Zhang. Shows they're training people who contribute to this level.
Good point. What about student recognition? Any awards?
Yes, definitely. Seongsu Heo won a Best Paper Award just this year, KSC 2024, for work on making something called sparse model inversion more robust. Again, thinking about reliability and efficiency.
Okay.
And last year, Yeon-suk got an Outstanding Paper Award at KSC 2023. His work was on efficient prompt learning, but in an incremental learning context.
So connecting prompt engineering with that continual learning challenge. Nice.
Yeah, keeping things efficient as the model learns over time.
Any other major conference hits recently?
Well, they had a paper at Colley's 2024 that's the specific conference for continual learning. Their paper was about better ways to replay information to prevent forgetting.
Using realistic latent vectors, it says here. Sounds technical, but important for that field.
And maybe the biggest splash recently, they got 2 papers into Tree AI 2024.
2 at Trey AI. That's a top AI conference, right? Getting 2 is quite something.
It really is. One paper directly combined continual learning with their human-like recall ideas using generative models. It was called Recall-Oriented Continual Learning. Something.
With generative adversarial meta model. Got it.
Right. And that one was even picked for an oral presentation, which usually means it's seen as particularly novel or impactful.
Wow. What was the other Trey AI paper?
That one was about knowledge distillation, transferring knowledge from one model to another, but doing it without needing the original data, called Teacher as a Lenient Expert, something like that.
Teacher agnostic data-free knowledge distillation. Okay. So focusing on efficiency and practicality again.
Exactly. So those AAAI papers together really showcase their focus, fundamental learning mechanisms like recall, and practical techniques for managing models efficiently.
And looking back at their older publications list, you see that database foundation too, right? Sigmod, VLDB, ICDE papers.
Absolutely. Papers like Pool of Experts in Sigmund 21, Split and Bridge, and Trick AI 21, which was about incremental learning. It shows a clear path from solid data systems work into these complex AI problems.
It suggests they understand the whole pipeline, not just the fancy AI model at the end.
That's a good way to put it.
And presumably, this kind of research needs funding.
For sure. And they list current and past grants. There's one called Deep Total Recall, which sounds like it's directly funding that human-like recall research,
Makes sense.
plus support from bigger national programs like AI Convergence and BK21. Getting these grants is another form of validation that their research topics are considered important.
Okay, so let's try and sum up what we've learned from the sources about the INHA Big Data Lab.
Well, they have this clear mission, AI for good, driven by making AI more accessible, scalable, and reliable, that ECR framework.
And they're tackling really key, tough problems in AI to achieve that.
Definitely. Things like continual learning, how AI learns over time without forgetting. XAI, making AI explainable. Federated learning, training AI collaboratively while protecting privacy.
Plus neural network compression to make AI run everywhere, and this ambitious human-like recall concept for better memory and adaptability.
Right. And it's all led by Professor Dongwon Choi, who brings this unique blend of deep database and data mining expertise together with cutting-edge machine learning.
And the output is strong, consistent publications in top-tier conferences and journals across ML, big data, and databases, plus awards for their students.
It really highlights how important those foundational computer science areas still are for pushing the boundaries of AI today.
Absolutely. And hey, if listening to this has got you thinking about maybe getting involved in this kind of research.
The sources do mention they have a vacancies section on their site.
Right, actively looking for BS, MS, and PhD students interested in big data and machine learning. So a direct path if these challenges excite you. So this deep dive gives you a snapshot of a lab really working on the practical challenges of making AI not just smarter, but also usable, understandable, and robust enough for the real world. It makes you think, doesn't it?
It does.
What would it actually mean if AI had something closer to human-like recall? Imagine an AI that could learn throughout its life without forgetting crucial past lessons.
How would that change things? Or AI that can genuinely explain why it made a recommendation.
Or AI that's efficient enough to run on the simplest devices, making it truly ubiquitous. As you think about the future of AI, consider which of those pillars, accessibility, scalability, or reliability, you think is the most critical bottleneck right now. Where should the focus be?
Something to mull over.